Hello everyone, welcome back to the channel and welcome back to the second part of this series, how to develop a native cross-platform application from scratch. In the first part of the tutorial, we have implemented API using Laravel and we have developed the front end for the web application using Vue3, Vuetify, TypeScript, Pinia for state management, and we have followed modular clean architecture with MVVM pattern. In this second part, we're going to follow the same structure. We will build the native application for the Android operating system with Kotlin and Jetpack Compose. And again, with using a multi-module feature-driven application and using dependency injection and all the good stuff. As usual, I would like to start from scratch so we can be on the same page. Let's create a brand new Android project, empty compose. The name of the application is going to be Pocket Goods and hit finish. In this tutorial, I'm going to use DSL, Kotlin DSL. So let's wait for a while. And after everything is done, loading and installing, we have an empty compose project. We're going to focus on how to prepare our projects in order to use multi-module approach. In other words, we're going to use features as modules with the same thing that we have done in the web version. We're going to create a core module, core UI module, and 3 features as modules. So in order to prepare the projects for module-driven approach, we will use the power of Gradle. We're going to explore a powerful feature in Gradle called build source. So basically, build source is a special directory, allows us to keep our build logic clean, organized and reusable across the entire project, or reuse it in different modules. Pretty much we can place common dependencies or custom Gradle tasks, utility functions, etc., and making them accessible throughout our projects. So we can benefit from type checking and code completion in our Android Studio IDE, which reduce significantly the errors and makes development smoother. And for reusability purposes, this is very handy because any updates you make in build source are instantly available to all modules, ensuring every module uses the same versions and configurations. And a side note, by using build source, we can speed up the build process by reducing the need for external scripts or repeated configurations. So let's switch to project, and I'm going to create new file or directory, and it has to be called build source. So by creating build source, Gradle will automatically recognize this build source because this is a reserved namespace. Inside this build source, I'm going to create a new Kotlin file. So it's going to be called build.gradle. So build.gradle.kts, and we're going just to add here the plugins that we're going to use. It's going to be only Kotlin DSL. So that's pretty much it. Now let's sync our application. By the way, make sure you have downloaded the latest Android Studio as well as the latest dependencies. Sync Gradle project. Inside the build source, or as you can suggest, I have some, I think this is a bug or something. The icon shouldn't look like this, but anyway, right click and choose directory. And there are some directories to choose from. We're gonna choose source main Kotlin. So inside this Kotlin folder, we're going to create an object that's gonna serve our configuration or project's configuration. What I mean with that is we're going to make our projects maintainable. Let's switch to Android, and here inside the scripts, inside the module, we're going to define an object that's going to contain these values, and we're going to use them here. So inside build source main, sometimes it's called Java, but here it's called Kotlin. I'm going to create a new file. It's going to be called, and again, it is an object. So projects configuration. You can call it whatever you want. So this is the configuration for this tutorial. So the namespace is going to be called, you can put your name here, and this is Pocket Goods. Namespace that we're going to use here in this Gradle file. Compile SDK, Java. We're going to set initially 1.1, the Java 11. If we have problem with Java 11, we're going to switch to 21 if ever needed. Application ID, it's going to be the same thing here, and minimum standard development kit, and going to use a custom test runner for our project. I prefer to do this, so going to use it afterward, but it's not necessary at this point. All right, next, I'm going to add some dependencies here, and perhaps I need to update the versions. Do not sync the project for now. Next, let's go to the root project. We have to update this Gradle file. So we're going to use KSP, and of course we are using health. Now let's add KSP and health to our TOML file. Now we have to define the plugins. Now I think we have to update this to the latest versions. Let's go. Don't worry about this. We're going to fix it afterward. Come back to the project or build Gradle module. And instead of using this plugins, we're going to use Compose and Android KSP. And for now, we don't need health. So I think that's pretty much it. Let's sync our project. No errors, that's great. Now let's use the stuff that we have defined here in project configuration instead of hard coding those values. Don't forget to add the test runner. I'm going to add it after finishing this configuration. So I have added the JVM, as I said. Initially, we're going to use 11. If we got problem during the project, we're going to use 21 or to switch to 21. And we have compose options, Kotlin compiler extension version, and I have added build configuration to true. So I think that's pretty much it. Let's sync now. As I said before, we have to add the test instrumentation runner actually in the source test folder. So in Android test, let's create here a new class. It's going to be called test runner. I would like to get rid of all the configurations and to do in this first section of our tutorial, so we don't have to worry about this in the next tutorial or the next video. So it's going to inherit from Android GUnit runner, and we have to override the function new application. Let's add here some comments. Add health test application. In order to make our build configurations reusable, we need to implement a custom Gradle plugin. Under Java or Kotlin, here we're going to create a new class, shared Gradle plugin. This custom Gradle plugin is going to be called shared Gradle plugin, defines a reusable centralized set of Gradle configurations for all our modules. It's going to help us to keep our build scripts clean, dry, and maintainable. This is the main reason why we're going to do this. We have to implement this interface plugin of type project, and we're going to override the function apply. So here we're going to define two functions. The first one is going to apply the plugins, and the other one's going to set project's configuration. Apply plugins, it will take in parameter project, and we're going to do project, apply only one plugin, which is DevTools KSP. Apply plugins. So instead target, I'm going to call it here project. And now we're going to add the other function that sets the project configurations. What I mean with that, we need to avoid reusing the same configurations as done here. Setting the namespace, setting the compile standard development kit, setting all of this, it's going to be handled by this function that we will create. That's going to be called set project configurations. This particular function is going to be used throughout our modules. I'm going to create another function or an extension function that will get the library extension by class name. So it's going to be called Android. It's going to return a library extension should be from Gradle, not from DSL. So it will return simply, so as suggested, it's going to be, that's correct, what the autocomplete has suggested. And we can use it project, Android, and apply. The first thing that we would like to set is the compile standard development kit. It's going to be available from our project configuration that we have defined before. The next one is the default configuration. Minimum standard development kit is going to be minimum standard development kit. For the test runner, this time around in other modules, we don't want to use our custom test runner. It's going to be just a normal test runner. So for the compile options, again, we're going to set initially the 11th version of Java version. If we encounter problems, going to switch it to 21. And for the target, it's going to be the same thing. So we have defined right now our custom shared plugin, and we have to call the function here set projects. The final implementation that I would like to have here in this Gradle file under app module. For example, if you want to use compose, I'm going to do compose in an argument project. Or for example, we want to use health dependencies. We're going to do health and projects here. Or for example, if you want to use our core UI or our core module, we're going to do, for example, a function. It's going to be called core, and it's going to automatically handle all the necessary dependencies for this core module. Or let's say, for example, the products feature. So you get the idea. So in order to do that, this is the main reason why we are proceeding this way. As you can see here, this is going to be very reusable throughout the available modules. So it's going to be a Kotlin file. We're going to call it dependency helper. It's going to be a normal file. The first method that I would like to use is to access the version catalog dynamically. So I'm going to call it version catalog. In parameter, it's going to be project. So in order to access the library from the version catalog, we're going to do return project and extensions get by type. So it's going to be version catalog extension and named library. Return type, it's going to be version catalog. To recap, this version catalog function is going to allow us to access the library or whatever we have defined here in the toml file. Now let's create an extension function that's going to represent all the dependencies that health is going to use, for example, in order to import the implementations. So I'm going to call it dependency. So it's going to be, first of all, on dependency handler solely for health, taken parameter project, and we can easily now access the library version catalog from the projects. Now we can add the implementation for health Android and KSP and implementation as you normally would in Gradle.kts. And we can use safely health. For example, in our build as Gradle, we can do health dependencies. As you can see here, we have autocomplete, as we have said in the beginning of the tutorial, and we're going to pass the project as an argument. Let's continue the rest. In our project, we need to deal with caching, right? A function that's going to handle the dependencies for room. Of course, you're going to use room database. So in the same manner, it's going to be called dependency handler, and let's call it room database. Another function, it's going to be for testing. And again, we're going to distinguish here between the dependencies used in normal environments and the dependencies that's going to be used in testing. So with the same manner, we're going to copy this. Instead of room database, we can add here testing. For room testing, we only need Android room testing, but don't forget to add those dependencies in toml file, because after running this, it's not going to know where is the dependency. It won't be found. In this tutorial, we're not going to use retrofit. Instead, we're going to use ktor clients. Of course, we're going to use compose. And I would like to define the dependencies that's going to be used for data module. We'll try to test our module implementation. We will use Turbine and the Kotlin coroutine test, Android JUnit, Android Espresso Core, and Kotlin client mock for mocking the ktor client, and JSON and the Kotlin test. The presentation module Android implementation. So basically, we're going to use this when testing our view models. Here we're going to test our repositories or use cases, and here we're going to test our view models to see if everything is working correctly. We're going to come back to this file later on to define the core or the core module of our application. In other words, the dependency that's going to be used for core module and the dependencies that's going to be used in core UI. So it's going to be reusable throughout the features, authentication projects, and authentication products and the wishlist. That's pretty much it, I guess, for the dependency helper. I'm going to create a new Kotlin file. It's going to be an object. Let's call it modules. So the main objective here is, for example, we can do const val. Let's do, for example, auth data. It's going to stand for the module for the data layer of authentication feature. We'll do feature and data. And we can use it again in dependencies. We're going to create again a new class or a new function that's going to handle for us the dependencies of this feature. So this is the main idea. So it's going to be empty for now. We're going to define accordingly the needed constants. So let's go to the TOML file and let's try to add all the needed dependencies that we will be using in this project. So basically this is the TOML file that I have prepared for this project. So I'm going to use accompanist for, I think I'm going to use it in the carousel, coil compose, constrained layouts, splash screen, and for Lottie animation, and JSON, hilt for testing, and Ktor, navigation compose, and room database. I'm going to use another package, security crypto, in order to secure our GWT token. Let's come back now to the build Gradle under the module application or app. You got the error first, and if you sync the project, the error is gonna go. I have changed or updated the module under app to this dependencies that we're gonna use in this project. Compose, idling for testing, for compose and mocking and tooling. Now, I would like to, because we need compose, I'm gonna do compose. We need hilt and we need room and room testing for testing purposes. For imagery, we're going to use coil. We will use accompanist for carousel. We have to use the splash screen. We need to use Ktor test implementation for Kotlin. Sync our projects first. And we have to uncomment this section. We didn't apply here the this plugin, so let's go. So just in case, in order not to get this error, aggregate error, in other words, method not found in Health, we're gonna do enable aggregation task equal false, just in case. We never know what's gonna happen. Let's sync again. One thing that we have to add here in the settings.gradle. So just for the .Lutty animation or Lutty animation library, we're gonna add here Maven, so according to the documentation. And for the repositories management, same thing. And let's sync the project. I think our project is ready to go. So just to make sure that we have done the correct steps, I tried to run the application, but I have encountered some problems and I have solved those problems accordingly. But basically what you have to do is just to make sure that you are using the latest versions and compatible versions. One thing that I had updated is the KSP. This is the latest version by the time recording this video. So this is significant because if you mismatch this version, you're going to end up with problems. I'm going to provide the TOML file in the branch that I'm going to call project setup. And again, for this, at the time I'm recording this video, the latest version of Gradle is 8.2.2. So we have done this at the end of the beginning of the video. And here there was a mismatch of the version. The latest version is going to be according to the Kotlin version, which is 2.2.10. At least in our TOML file, we have the Kotlin version 2.2.10. And I have run the application and again, we have no errors. So if you pass this step and you have some errors, just try to make the correct versions as I showed you before. That's pretty much it. That's gonna wrap up our video. For the next video, we're going to create our first reusable module. It's gonna be core module for this application. I hope you liked the video. See you in the next one and happy coding.